Kenya's last mile renewable grid, lighting the future without fossil fuel. Picture a primary school in a remote village in Kenya's arid Turkana County. A decade ago, as dusk fell, lessons would stop. The only light came from the faint smoky glow of a kerosene lantern, and the only power for a phone or radio was a distant trading center with a diesel generator. Today, that same school is illuminated by bright LED lights powered by the national grid. A solar powered water pump provides clean water, and a teacher uses a laptop to download lesson plans. This transformation is not isolated. It is the result of a deliberate data driven national mission that has achieved a milestone once thought impossible for a developing nation. A near universal electricity grid powered almost entirely by renewable energy. Kenya's announcement of reaching over 95% national connectivity is more than a statistic. It is a rewriting of global energy access playbook. The backbone of this achievement is Kenya's foundational commitment to harnessing its abundant natural resources for generation. While many nations with growing energy demands have turned to coal or natural gas as their baseload, Kenya invested heavily in geothermal power, tapping into the vast heat reserves of Great Rift Valley. The result is a national energy mix that is approximately 90% renewable, dominated by geothermal, complemented by significant wind power from projects like the Lake Turkana wind farms, Africa's largest and utility scale solar and hydropower. This renewable foundation is the first critical data point. It means that every new connection added to the grid carries a disproportionately low carbon footprints. The environmental calculus is clear. Connecting a rural household in Kenya to the grid has a fundamentally different climate impact than connecting a similar household in a country reliant on coal or gas. Kenya's grid emissions intensity stands at roughly 25 gram of carbon dioxide per kilowatt hour, compared to a global average of over 400 grams and figures exceeding 700 grams for some coal dependent grids. This establishes a paradigm. High energy access and low emissions are not sequential goals but can be pursued in tandem. The true test of this mission, however, was not generation but distribution. The last mile problem. How do you cost effectively connect scattered, low density, and often low income rural communities where extending the traditional grid is prohibitively expensive? Kenya's Rural Electrification and Renewable Energy Corporation employed a suite of innovative data informed solutions. The strategy moved beyond a one size fits all approach, where feasible traditional grid extension was used. But for the most remote settlements, REREC deployed standalone solar home systems and interconnected solar mini grids. The data from this rollout is staggering. In the final 18-month push to reach the 95% threshold, the program connected its 1 millionth new household. The scale of this logistical operation, targeting the hardest to reach populations, is a monumental achievement in rural infrastructure management. The impact of these connections is quantified in both environmental and human terms. It is estimated that displacing kerosene lamps, diesel generators, and battery powered torches with clean grid and solar powered will avoid approximately 2 lakh tons of CO2 emissions annually. Beyond the carbon, this eliminates indoor air pollution from kerosene, a major cause of respiratory illness, and provides stable, high quality power for education. Now, let us see why this is a replicable blueprint for Global South. Kenya's success provides a powerful evidence based counter narrative to a long held assumption that developing nations must inevitably pass through a phase of fossil fuel dependency on their path to universal electrification. Kenya has demonstrably leapfrogged that phase. First, it proves that the technical and economic viability of a renewable first grid at a national scale. The reliability of geothermal provides baseload stability, debunking the myth that high renewable penetration leads to an unstable grid. Second, it offers a masterclass in adaptive rural infrastructure management. By utilizing a technology agnostic toolkit, main grid, mini grids, and standalone systems tailored to settlements pattern and economic activity, Kenya maximized efficiency and speed. This flexible model is directly applicable to other nations with diverse geographies, from island nations to vast continental interiors. And third, it demonstrates the profound socio-economic multiplier effect of clean energy access. Reliable electricity boosts agriculture processing, supports digital education and telemedicine, and enables small businesses to operate after sunset. A 2023 study on Kenya electricity access project already indicated a 16% average increase in household income for newly connected rural families, with significant gains for women-led enterprises. The challenge now shifts from the connection to sustainability. Maintaining this vast and technologically diverse network, ensuring affordable tariffs for the poorest users, and managing the growing demand as economies electrify are the next hurdles. The data show that the connected households rapidly acquire more appliances, a testament to power's utility but also a new demand pressure on the grid. Yet, Kenya has laid the most critical foundation. It has built a 21st century grid in the 21st century, not replicating the carbon intensive models of the past. So, this shows that the sustainable rural development is intricately linked to clean energy access. By providing light, power, and opportunity without mortgaging the climate future, Kenya has illuminated a path for the world to follow. Thank you.